Hey everyone, welcome back to the channel. If you're preparing for the AWS Certified Cloud Practitioner exam, the CLF-C02, then you're in exactly the right place. So let's get started. Let's look into the question itself. I'll read it out first, along with all the options. No answers yet. We'll go through those together in just a moment. Here we go. A retail company is planning to migrate its on-premises data warehouse to the AWS cloud to reduce operational costs and improve scalability. They want to understand the potential benefits before beginning their cloud journey. According to AWS Cloud Transformation Principles, which of the following outcomes is most likely when leveraging cloud for technological transformation? Option A significant increase in downtime due to complex migration processes, reducing overall service reliability. Option B, a reduction in cost per user, higher VMs managed per admin, decreased downtime, and fewer security events. Option C, a minor improvement in operational efficiency with no impact on security or administrative overhead. Option D, no measurable change in cost, operational metrics, or security since cloud migration only impacts infrastructure. All right, that sets the stage. Now let's walk through this slowly in a way that makes the concepts easy to digest, because this topic of cloud transformation benefits is a favorite in the CLF-C02 exam. And you might be thinking, well, yeah, the cloud sounds cool, but what actually improves when companies migrate and why? Okay, so let's break this down together. When AWS talks about technological transformation, they're referring to something bigger than just lifting and shifting a database into EC2 or S3. They're talking about modernizing, moving from old, rigid on-prem systems into scalable, automated, highly available cloud environments. Think of it like going from driving an old manual car with sticky gears to a smooth, modern EV that practically drives itself. Now, before we jump to the correct answer, let's walk through each option like we're doing this together on a whiteboard. Option A says there's a significant increase in downtime. Now, does that sound like AWS? Probably not. Sure, during migration, there can be small controlled downtimes or planned windows, but AWS's whole value proposition is reducing downtime long term. The cloud gives you automation, fault tolerance, health checks, managed services, all the good stuff. So if anything, over time, organizations see less downtime, not more. Option C is interesting because it claims only minor improvements and no impact on security or admin workload. If you've ever seen AWS talk about automation, IAM, security services, managed operations, you can already tell this doesn't line up. Moving to cloud definitely affects operational efficiency and security posture in big ways. And option D, well, this one almost reads like a trick. No measurable change. That's the opposite of what almost every cloud value study shows. AWS literally publishes annual benchmarks showing very measurable improvements: cost, performance, agility, security, the whole package. So now you're probably leaning toward one option already, but let's really connect the dots. Hang on, because this part's super important. AWS did a massive cloud value benchmarking study where they looked across companies that migrated. And here's what they found, and this is the part you want to remember for the exam. Companies saw a 27% reduction in cost per user, a 58% increase in VMs managed per admin, a 57% decrease in downtime, and a 34% reduction in security events. Those are not small improvements. Those are huge, measurable, business-changing results. So when you hear that kind of metric, which option does it map to? The one that mentions cost savings, improved admin efficiency, reduced downtime, and fewer security incidents. And that brings us, of course, to the right answer, option B. Now let's go deeper for a moment. You might be wondering, why does this actually happen? Why does the cloud reduce downtime? Why does admin efficiency go up? Why does security improve? Great questions. It's because when you're on-prem, you're babysitting hardware, you're patching servers manually, you're worrying about physical machines, power, network failures, you're doing everything yourself. But when you migrate to AWS, suddenly you're using managed databases like Amazon RDS, managed analytics services, auto-scaling, automation, monitoring tools, cloud-native security controls, and others. And when all that kicks in, admins can manage far more resources. Systems become more resilient. Security becomes proactive instead of reactive. And your cost model shifts from CapEx to OpEx, meaning you pay only for what you actually use. So what does all this really mean for you, the exam taker? It means whenever the exam talks about cloud transformation, especially technological transformation, you should think modernization, operational efficiency, better security, reduced downtime, automation, and cost savings. Those are the keywords. Those are the concepts AWS wants you to associate with cloud adoption. Let's look into the fourth question. A company wants to implement a third-party application purchased from AWS Marketplace and needs assistance integrating it with their existing AWS infrastructure. Which partner type should they engage for this service? And here are the options: system integrator, SI, independent software vendor, ISV, AWS Marketplace solution architect. All right, now that we've got the options on the table, let's walk through this like we're solving it together. So this one's really interesting because on the surface, all of these sound like they could help you in some way, right? You've got SIs, you've got ISVs, there's the marketplace itself, and of course, AWS solution architects. If you're new to the AWS ecosystem, it's totally normal to mix these up. But hang on, this is where understanding the roles of each player makes all the difference. Let's break them down one by one, nice and easy. First up, system integrators, or SIs. These are the folks who basically act like your hands-on builders, your cloud plumbers, your tech electricians, whatever analogy you want to use. If you buy something from AWS Marketplace and you're thinking, okay, now how do we get this thing plugged into our VPCs, our IAM roles, our databases, our logging, all that stuff? That's exactly where an SI shines. They don't just install the product. They integrate it into the bigger AWS picture your company already has. So remember that image. SIs don't create the software, but they make everything work together. It's like getting a brand new smart thermostat. You can buy it, but someone still has to actually put it into your home's electrical system and connect it to your Wi-Fi without blowing the fuse box. That's your system integrator. Now, let's contrast that with ISVs, independent software vendors. These are the people who build the applications you see on the AWS Marketplace. If you see an antivirus solution, a data governance platform, an observability tool, chances are an ISV created it and published it on AWS Marketplace. But here's the thing. ISVs usually stop at making the software. They're not the ones who come into your environment and integrate the whole thing. Sure, they might offer support or documentation, but they're not your hands-on technical team. Then you've got AWS Marketplace itself. And this one can be a little confusing. A lot of people think the marketplace is like a service provider, but really it's just the storefront. It's like Amazon.com, but for software. You buy, you subscribe, and that's it. The marketplace isn't going to jump into your VPC, configure load balancers, set up permissions, or stitch the app into your event pipelines. It's just the platform where you get the tool. And finally, we've got the AWS Solution Architect. These folks provide guidance. They're like your technical advisors. They help you map out architectures, choose services, figure out best practices, but they're not implementation engineers. They don't log in and deploy the app for you. They don't manage ongoing integrations. They don't maintain third-party tools for your environment. Think of them as cloud consultants, not the hands-on technician actually wiring things together. So now let's circle back to the heart of the question. A company has purchased a third-party app from AWS Marketplace, and they need help integrating it into their existing AWS environment. So what does this really mean for you? Well, the keyword here is integrating. Not purchasing, not developing, not architecting, integrating, making two worlds talk to each other, your current AWS setup and this shiny new marketplace application. That's the bread and butter of the system integrator. They don't just say, here's what you could do. They actually do it. They jump into your IAM, your networking, your security structure, your CI/CD pipelines, your logging systems, whatever you've got, and make sure this purchased solution becomes part of your environment smoothly and securely. So the correct answer here, System Integrator SI. And honestly, this makes perfect sense. When you're dealing with third-party software, especially at an enterprise level, you absolutely want someone who knows AWS inside and out and knows how to piece all the moving parts together. You don't hire the software creator to rebuild your architecture. You don't ask the marketplace to do integration, and you don't rely on a solution architect to manage deployment. You bring in the people who specialize in exactly that, system integrators. So that's the real takeaway here. When AWS Marketplace apps need to be woven into your cloud ecosystem, SIs are the ones who make that transition seamless. Let's look into the fifth question. Here it is. A development team is using AWS Lambda for a data processing application. The function uses container images. The team wants to know how patching responsibilities apply in this setup. Which statement accurately reflects this shared responsibility? And here are the options. AWS patches the container image automatically during deployment. AWS manages execution environment, but not customer-supplied container images. The customer must redeploy functions with updated container images. Customers must rebuild and redeploy Lambda functions with updated container images, including security fixes. All right, now that we've got the question and all the options on the table, let's break this down together. Now, this one's really interesting because AWS Lambda is serverless. And a lot of people hear serverless and think, great, I don't have to patch anything. AWS handles it all. And, well, kind of true, but not entirely. That's where understanding the shared responsibility model becomes super important. So first, let's remind ourselves what Lambda actually does. Lambda lets you run your code without managing servers. You simply upload your code, or in this case, your container image, and AWS runs it. They handle scaling, infrastructure, operating system, network, and the security of the execution environment. Basically, they make sure the platform itself is safe and running smoothly. Sounds amazing, right? And it is, but here's the twist. If you're using your own container image, AWS doesn't automatically update that image for you. That's your responsibility. Think about it like this. Imagine you've built a little container with your app inside. You place it on a server that AWS manages. AWS patches the server, keeps it secure, and monitors it to ensure uptime. But the app inside your container, that's your code. If it has security vulnerabilities or needs updates, AWS won't do that part for you. You've got to handle it. Hang on, because this part is super important. When you're using custom container images with Lambda, every time there's an update, whether it's a new library version, a bug fix, or a security patch, you need to rebuild your container and redeploy it. AWS secures the underlying platform, but your container's contents, that's on you. Now let's quickly look at the options and see why some of them might seem right but aren't quite accurate. Option 1 says AWS patches the container image automatically during deployment. That sounds nice because AWS is great at automation, but nope. AWS only manages the execution environment, not your custom images. Option 2 says AWS manages execution environment, but not customer-supplied container images. That's true, and it's actually part of the explanation, but it's not a full answer because it doesn't include the customer's responsibilities. Option 3 says the customer must redeploy functions with updated container images. Closer, but still not complete. It's not just redeploying, it's also about rebuilding and applying security patches before redeployment. And then we have option 4. Customers must rebuild and redeploy Lambda functions with updated container images, including security fixes. Bingo. That hits the nail on the head. That captures the essence of the shared responsibility model for Lambda containers. AWS manages the platform and environment while you manage your container code and dependencies. So why does this really matter for you? Well, AWS loves to test your understanding of shared responsibility, especially in serverless contexts. It might seem like serverless is hands-off, but ignoring your container updates can create security risks. Knowing this distinction helps you eliminate wrong answers quickly on the exam. So what's the takeaway here? Remember this mantra. AWS secures the platform, you secure your code. Keep your containers updated, apply security patches, rebuild your image, and redeploy. That's how you follow best practices while keeping your Lambda functions safe. And that wraps it up. Understanding this shared responsibility model doesn't just help on the exam, it's also critical in real-world serverless architectures. Serverless doesn't mean zero responsibility, it just shifts it. Keep your container images patched, functions redeployed, and you're good to go.